Hi Year 10, we're going to talk about quadratic graphs today. This is page 11 of the Algebra 3H pack, and it's all about finding the roots and turning points of quadratics, or just identifying them from a graph. Okay, not much of this page will be me sort of giving you an intro and then just letting you get on with it, because as you can see there aren't that many practice questions. So by all means, I'd probably have a go, probably watch the Maths Watch clip or the Corbett Maths clip on this, have a go at it, and then just watch this video to check your work. Okay, so we've got a graph here of a quadratic, x squared minus 2x minus 3. You can see it's a quadratic from its parabola shape. And hopefully you remember that from a quadratic, we know which way round it is, whether it's positive or negative x squared. Okay, so if it's a positive x squared graph, in other words, if the coefficient of x squared is positive, it will make this U shape. If the coefficient of the x squared term is negative, it will kind of make an N shape. Okay, if you try and remember N for negative. Right, we've got to find the turning point of the curve. Now, I appreciate you won't have heard of the turning point probably before, but no prizes for guessing where it is on the graph. It's the point where the graph stops going down and starts going up. Okay, so here's the turning point. And the coordinates of that are 1, negative 4. Couldn't find an easier question. Part B, find the coordinates of the roots of the equation. Now the roots of an equation could also be called the solutions of the equation. Okay, and all that factorising we've done on the previous pages was to find the solutions of the equation, which tells us where the graph crosses the x-axis. So that's in two places for this graph. Sometimes quadratic graphs don't even cross the x-axis, sometimes they just touch the x-axis, which would give one solution. But this one crosses, so therefore there are two roots, two solutions. We don't have to factorise this to find them, we can just see them here on the graph because they go through nice points. Now, just be careful to check whether it's asking for the coordinates or just the roots, because if it just wanted the roots, we could just write down negative 1 and 3. But because it wants the coordinates, we're going to have to give that as coordinates, and that will be negative 1, 0, and 3, 0. And then finally, the intersection of the curve with the y-axis, in other words, the y-intercept, that is here, just like the y-intercept is on a linear graph. It's where it crosses the y-axis, and that is at 0, negative 3. Okay, number 2. Emilio wants to sketch the graph of x squared minus 7x plus 10. Find the value of y when x is 0. So in other words, find the y-intercept. When x is 0, when the x-coordinate is 0, we are on the y-axis. Okay, so what we do is we substitute x equals 0 into this equation in two places and see what we're left with. So we're left with 0 squared minus 7 lots of 0 plus 10, and this would just give us 10. So we're just left with this term at the end. Much like the constant term on its own that doesn't have any x's next to it in a linear equation is the y-intercept, it's the same in a quadratic equation as well. Okay, so you can easily identify the y-intercept of a quadratic graph. As long as it's y equals, it will just be the number on its own. Okay. Part B says, use your answer to A to plot where the graph crosses the y-axis. Now this is just a sketch and there's no numbers on this grid, so I'm just going to say that that is 10, so it goes through there. C, solve the equation. Remember from a few pages ago, we would solve a quadratic equation. Well, factorising would be our go-to method first. So we've got x in both of these brackets, looking for two numbers that multiply together to give 10, add together to give negative 7. That's going to be negative 2 and negative 5. So to make those brackets each 0, x would have to be 2 or x would have to be 5. And those are our roots, or solutions, remember, another word for root. Okay, so this graph crosses through at 2 and 5. It doesn't have to be perfect, your sketch. Part D, use your answers to C to help you plot where the graph crosses the x-axis. There it is. And part E, sketch the graph. So we know it's a positive x squared graph, so it's going to make a parabola like that. and we know it goes to those points. Okay. Number 3, the graph of y equals x squared minus 1 is shown. What are the coordinates of the turning point? Turns at this point here, so that's coordinates again, 0, -1. And what are the coordinates of the roots of the equation? So in other words, the solutions, you can also see them quite easily on the graph, here and here. So that's -1, 0, and 1, 0. Okay, a little bit more challenging now. We've got 4 equations of quadratics and 4 sketches of the graphs, and we've got to match them together. So just looking at these graphs first, only one of them is an upside down parabola, if you like, an n-shaped one. So we're looking for something that would have -x squared as one of its terms, or it wouldn't have to be -1x squared. It might be, there might be a number there as well, but it will definitely be a negative in the x squared term. This one's positive, as we can see. This one would expand out to give us a positive. We'll come back to do that later if we need to. This one will also give us a positive x squared. Now this one, as we times those together, it will give us x squared, but the final thing is that we make everything negative, so this is the only one that's going to give us that upside down parabola. So equation C matches graph 2 because it's the only negative x squared equation. Therefore, that shape. Okay, now so let's see anything else that will help us. So this one has already been factorized. I'm now looking at the equations here. This one's already been factorized, so from that I can immediately take the roots quite easily. So the roots that would make this 0, x equals 6, and x equals -8 are the roots. So something with 6 at -8 are the roots. Now this, it could be that, couldn't it, by the looks of things, but we've already used that graph. So that one doesn't have any roots, so it can't be that one. This one has 2 roots, but they're both positive, so it can't be that one. So it must be this one. So that point there must be 6, and that point there looks a bit further down the axis, the x-axis there, at -8. So B matches 4. Because roots at -8 and 6. Okay, so we've done that, and we've done those ones. Okay, so 2 left. Finally, let's see if we can factorize this one. So anything we can multiply together to get 8, add together to get -6, yes, we can do -2 and -4, which would mean my roots are x equals 2 and x equals 4. So that must be this one here. Okay, so A matches 3 because it has roots at 2 and 4. Okay, and this one is my last one left over. The other thing we could have done to help us identify some of these graphs is maybe to think about the y-intercept. So this one has a y-intercept of 8, B was 4, so -6 times +8 will be -48. So that's the only one with a negative y-intercept. Okay, graph C matches equation 1. You cannot solve this equation. It's not factorizable, so it doesn't have any roots. Okay, so we just say that it has no real roots. You might be wondering why we've used that word real. Well, if you carry on with maths and go to do further maths, you come across something called imaginary numbers, and this is where this plays a part, but I won't go into that now. Okay. Part B, write the coordinates of the points Q, R and S. So we've identified some of those already. So Q is on graph number 2. It's the lower root, and that was this one, and that will be -8. So -8, 0. R is here, we've shown where that is already, that's at 4, 0, and S is at 0, -48. Okay, and just a reminder, that was by expanding this out, and that would give us x squared plus 2x when we've simplified, minus 48, but then when we go through them, times by this negative, that becomes negative, this becomes negative, that becomes positive. Right, number 5, sketch the graph of y equals x squared minus 6x plus 5 by finding the roots and y-intercepts. Let's start with the roots. So if it's got roots, hopefully it'll be factorizable, and those roots will be whole numbers. So we're going to set this equation equal to 0 and make a pair of brackets. Two numbers at times together to make 5, add together to make -6, -5, and -1. So the roots are 5 and 1. And the y-intercept, very easy to spot, is that number on its own. Okay, so it goes through 5, 1, and 5. That's enough information to draw a sketch. It'll be a very wobbly one. Let's try that again. Okay, and part B, there is a way to find the turning point using the equation, but we're not going to go through it now. It's called completing the square. In fact, one of these up here was in completed square form, and that actually tells us where the minimum point is, but we won't go through that now. We'll save that a bit later on. But we can also find it by considering the roots. If you've got the roots, the graph is symmetrical, and the lowest point or highest point, the turning point, in any case, will be halfway between the roots. So if we can find the x-coordinate that is halfway between 1 and 5, then we've got a start. Okay, so halfway between 1 and 5 would be 3. We just need the y-coordinate. So what we'll do is we'll take that x-coordinate of 3, we'll substitute it into the equation, and it will output a y-coordinate. So 3 squared would be 9. Take away 6 lots of 3, so take away 18, that would be -9, plus 5 would be -4. So that is the turning point of the graph. Looking at our graph, looks about right. Finally, number 6, Michael wants to sketch this graph, find the value of y when x is 0, so the y-intercept. We can already see it will be 64, because 0 squared plus 16 lots of 0 would just give 0. So 64 is the y-intercept. Use your answer to part A to plot where the graph crosses the y-axis. Done that already. Solve the equation. Okay, so x plus 8 and x plus 8 multiply together to give 64. So x is equal to -8. Now this would give us the same root. So there's only one solution. Part D, use your answers to C to help you plot where the graph meets the x-axis. So it meets the x-axis, it doesn't cross it, it just meets it at -8. So it just sits on top of the x-axis. And finally we've got to sketch it. So it will look something like that. Thanks for watching.